A geometric series has first term A and common ratio R. The sum of the first and second terms of the series is 72. The sum of the first and third terms of the series is 120. Show that R satisfies the equation 3R squared minus 5R minus 2 equals 0. Given that the modulus of R is less than 1, find the value of R and the sum to infinity of the series. So let's have a look at this then. I've got the question summarized here. So let's have a go. So the sum of the first and second terms is 72. It's a geometric series, so A plus AR is the first and second term. That's equal to 72. And then the sum of the first and third terms, A plus AR squared, is equal to 120. That's number 2. Okay, so here we can see that A, take it outside a bracket, 1 plus R, is equal to 72. And here we can see that A, 1 plus R squared, is equal to 120 if we take the A outside a bracket. So we can then substitute A, can't we? So the A, which will be 120 over 1 plus R squared, that's A, times 1 plus R, must equal 72. And that tells us now then that now the top, I'm going to expand the top. No, I'm going to leave it as is, move this up there. So 120, 1 plus R, is equal to 72, and move this term from divide over to times 1 plus R squared. So 72 divided by 4 is, no, divide by 6 or 12. That would be, if I divide by 12 I get 10, and divide this by 12 I get 6, and now we can divide by another 2. That's 5, and this is 3. So we end up with 5 of these, so that would be 5 ones is 5 plus 5R is equal to 3 of these. That's 3 ones are 3 plus 3R squared. And now let's move everything over to the right hand side and read from right to left. 3R squareds. Move this over, minus 5R. And then we've got a 3, move the 5 over to minus 5. 3 minus 5 is minus 2. So there's our quadratic which we wanted to show, which we've done. Now given the modulus of R is, so that was part A. Now part B. Given the modulus of R is less than 1, find R. So we need to factorize this. 3R. R. It's going to be 2 and 1, isn't it? Here we'll have a minus, here we'll have a plus. So that tells us then, because the modulus of R is less than 1, this is not a solution. So that tells us that R is a third. A minus 1/3, isn't it? R is minus 1/3. And S infinity. So if R is minus 1/3, then we can get A, can't we, from either of these? So let's have a little look at them. So A is equal to 72 over the 1 plus R. 1 plus R is 1 minus a third is 2/3. So 3 moves up, 2 goes into 72, 36 times 3 is 108. So A is 108, R is minus 1/3. So S infinity then is equal to A, 108, over 1 minus R, which is minus 1/3, so that's plus a third. 108 over 4/3. Let's work that out then. So that's equal to then 4 into 108, 54, 27. 3 comes up, 3 over 27 is 1 over 9. We can tap that in the calculator if we need to.